Give me approximately 10 seconds.
Everybody's out there. Okay, all right. Hello, everyone. Thank you for coming to Lunchalytics today. We're going to talk about Internet of Things analytics, and we have two really great presenters with us. We have Brian Kmet from PCL and Bruce Matichuk from HealthGauge. And we, as you know, we live stream it, so that's why we have to wait till noon. But before I move forward and have the presenters, just a couple of things. So one, we always want to be thankful to our sponsors who really allow us to have Lunchalytics and pay for the lunch that you're eating now. So we are the founding sponsor, but we have ATB, Go Auto, Nate, Alberta Data Partnerships, and Startup Edmonton, also as the community together. And to celebrate the ending of this fourth year, we're actually going to change it up a bit for the last one. So I don't know if you guys saw it on Meetup. On the June session, which is June 19th, instead of doing Lunchalytics here, we're actually going to do evening. We don't want to change the name, but it's going to be like Supperalytics. And we're going to do it at the CQUA Performance Space, which I think is beautiful because it's all windows in June. It's going to be like the longest day of the year. And we're going to have two great speakers, and we'll make it a longer session. So we're actually going to do it 2 hours. And we're going to provide some drinks and some hors d'oeuvres. So come out to that. It's going to be a health theme. So Russ Greiner from U of A will talk about AI in health. And Dr. Lou, I'm going to try to say his name. I think it's Franceschetti, but he's going to be talking about virtual ICU, this concept that he's putting forward to kind of reduce the strain on the healthcare system with homeless people who keep kind of recurring into the hospital. So I think it'll be a really interesting talk. So we'll see you guys for that in June. And then May, still to be determined what we're going to do, but if I can make something happen on election, that's really what I would love to do, but we'll see if I can get some speakers to talk about that. All right, so without further delay, I'm going to introduce Brian. Actually, Brian will probably introduce himself. This is the best thing that's happened today. He said that he saw us, an article in the Edmonton Journal about Dark Horse many years ago about emergency services and predicting where the stations for locations, and actually one of his inspirations for moving into this field, which I thought was amazing, and I think we should put that on our website.
Sure, I'm in. Thank you. I guess you'll get me into PowerPoint mode here.
Yes, I will do that.
Please.
Okay.
I want to start there. That's okay. If you could put me to the beginning.
Yeah.
Just beginning. Sorry.
No, that's my fault.
Great, thank
Okay.
you. Good afternoon, everyone. First off, it's a pleasure to speak here. Thank you for the opportunity. I was shamelessly perhaps promoting Dark Horse, and I'm going to do the same for PCL, so bear with me. I've got to take a marketing opportunity when I get one. I'm going to talk today about analytics at PCL in general, very high-level overview, what we've done, our machine learning forays, and a platform we've built called JobSite Insights, which is totally focused around IoT technology and machine learning and artificial intelligence in the construction space. The construction space is notoriously unproductive. If you read McKinsey at all, this sector hasn't grown versus other economic sectors in years, for the past 80 years. It's a poor performer. So anything we can do to advance that needle is welcome. By introduction, I'm the senior manager in our IT group known as Business Technology. I have the privilege of running our data teams, our analytics teams, and the back of house operations as well. I'm still saddled with ERP. That's never going away from me. It's just part and parcel of our business and every business. So what I wanted to start with is who is PCL? For those of you that don't know, we built the lovely arena just across the street from us. We're a private company, 100% employee owned. We do about $8 billion in revenue a year. At any given time, we have, these numbers vary, but we have 700 plus projects underway, 5,000 professional staff, or 4,000, I always get that number mixed up. And depending on work volume, upwards of 15,000 field staff, or what we call craft workers. Again, all driven by work volumes. PCL is very sensitive to the environment. I'm going to brag about that here shortly as well. Where environmental stewardship is part and parcel of why we're doing our IoT and analytics. And we believe in giving back to the community. I mean, we're very big with the United Way here in Edmonton, and it's part and parcel of our culture and our heritage. So that's the 10,000-foot view of PCL. We operate primarily in Canada and the United States, and we have operations and construction activity in the Caribbean and in Australia, where we built a cancer center. And So how did this begin? So 4 years ago or 5 years ago, we had a new CIO who hired me. And we launched our digital first operating model, our digital transformation, if you will, which in construction is somewhat revolutionary. Other companies are following suit. We like to think we're leaders in this space. And we really began with 4 tenets: data and analytics, mobility, data anywhere at any time, cloud and SaaS. We've moved entirely to cloud. We don't have a data center anymore. And of course, data integration is part and parcel of what we do in the teams that I run. Going forward, our new platform, we used to call those our 4 pillars. We're getting into virtual construction, augmented reality, and then of course what I'm here to talk about today is IoT and AI and ML. So those are the fundamental core tenets of our technology strategy and our technology platforms. And I'll briefly, in 15 minutes as best I can, run through what we're up to and describe to you what we're doing. I won't have a lot of technical detail. If you want to speak to me afterward, happy to talk about it. So here's where I get to blow our horn. We received the PwC Vision to Reality Award last year for our digital transformation efforts. We competed with a lot of great companies. And the thing there's me leaning to the left. There's my boss, our CIO, and a couple of my peer managers. What was interesting about the press release is everything was data, data, data. You know, this is all about data. That's everyone says it's the new fuel of the economy. It really is for us in construction because we generate a lot of data in construction. Like, it's remarkable. One of our IT guys told me that we're an Azure customer and we are the largest data tenant in the Microsoft Azure platform. That is, we have more data than anybody up in the proverbial Azure cloud. It just gives you a sense of the data. We don't do anything with it. For long times, we collect it and we don't do anything with it. So a lot of our efforts around this are changing that. Everybody's seen this P-pod. I call it the P-pod of analytics, where we move from, descriptive analytics, predictive analytics, or predictive and then prescriptive or optimization. I always put the value equation over here because everybody's always going to do this. Everybody's starting to do this, and people are moving into this space. That stuff's never going to change for us. We do a ton of descriptive analytics. We always will. And I don't think there's any less value to it as described by a typical, what I call the P-pod chart of analytics. There's no difference for us. There's certainly more challenges in here, and it's harder to do than standardized reporting. But for us, it's a continuum that's represented in the value chain in a vertical axis. It's just part and parcel of what we do. So I'm going to take you through some of our descriptive stuff and what the stuff you guys came to hear about of what we're doing today in the prescriptive areas or the predictive areas or the machine learning areas and how we're tying IoT together with all of that. And of course, our goal here is this. It truly is decision automation. We want to take the human factor out of monotonous, boring stuff in the construction field where we can and add value to our construction operations and let the people that earn money with a shovel in their hand drive the value for PCL, a low margin business, highly competitive, and as I said, highly unproductive. It's one of the most unproductive sectors in the economy. It also consumes a lot of natural resources. The materials that go into it, there's a lot of carbon emission in construction, and we're aiming to reduce that. So, again, I get to brag one more time. We really began our analytics journey about 4 years ago with project analytics, construction project analytics. We won an award from the Information Technology Association of Canada. At LAWA, Los Angeles World Airport's billion-dollar project, we were asked to combine data from the owner, a joint venture partner, and ourselves into what you guys know as dashboards, the simple dashboards. We did it in 30 days, and our executives were astounded and said we couldn't do it, so we took the challenge. So our project analytics really got us started with an analytical program. And what did that look like? We addressed 4 domains: financial or cost, quality, safety, schedule, RFIs, and submittals. Those are fancy words for lots of documents. Construction generates a boatload of documentation, legal documentation, regulatory documentation, and our own internal documentation. So if you haven't guessed by now, we're a big Microsoft customer. We use Power BI for our descriptive analytics, our ad hoc reporting. And these dashboards have grabbed hold in PCL like wildfire. Every single project, 700 plus projects at any given time, is using our descriptive dashboards. Biggest outcome from all of this, it's not the graphs, it's not the numbers, it's not the data. It's fueling data-driven decisions and, more importantly, fueling conversations. conversations that never used to happen in the construction field. Case in point, on this particular project, there was a piece of work where the superintendent responsible for it said, "I'm not behind schedule." Well, dashboards say otherwise. So rather than chastise the guy because he's behind schedule, it got a conversation going about why are we behind schedule. And for me, this has been the biggest outcome of our descriptive analytics, is it's driving conversations. It seems strange, but that's really the benefit we've realized from descriptive analytics in our Azure platform. Machine learning, this is really cool. This is the stuff that excites me. We generate a boatload of data, as I said. It's unbelievable the amount of data we have. We don't do anything with it. So what did we do in machine learning? This was one of my pet projects. It's still underway. It's relatively new. We do hazard inspections on a construction site because for PCL, safety is our first priority. We have the lowest lost time frequency rate in the industry. That's a metric that is the gospel for safety professionals. And what we're doing is we realize that guys on a job site, everybody has an iPhone, and they walk around taking pictures. Because what they do is they go back to the trailer, they write their safety report, and they've got the picture in their hand, and they go, yeah, that's my reminder. So we said, let's capitalize on that. So we built an app with an iPhone, any device actually, where a safety professional or a superintendent or those responsible for safety will take a picture, and we have a natural language processing algorithm that correctly classifies the job hazards according to our health and safety operations manuals. It used to be a long, monotonous, boring, time-consuming process. We've also used computer vision on the phone to categorically find the hazards. So this is a random picture I selected. It's not the real deal, but we actually draw a cute little box around the hazard. The superintendent will take his phone and say, I'm observing an excavation that has insufficient protection from fall, and we classify that hazard. A couple of benefits from that: we're using data science to correctly classify a hazard. We're getting accuracy rates in the 90% range. The models are learning as we speak and as we use this. Widespread adoption and a really innovative use of natural language processing and computer vision technologies. So I'm particularly proud of this because we want to send people home at night in the same condition that they arrived at work. It's hugely important. And unfortunately in construction, it is a dangerous profession. Things happen. And we're really trying to ensure that our lost time frequency rates, our total recordable incident rates are minimized. Job site insights. This is IoT. So what we've done on a job site is we've instrumented the job site with IoT sensors. I think in the old days they used to call that a sensor. I don't know why IoT crept in, but everything's network enabled these days. So what have we done with this? I've got a quick 2-minute video just to give you a sense of what this is about, and I'll get into a few more details.
PCL is a 110-year-old company founded in Saskatchewan. We operate in heavy industrial, civil construction, and buildings. Our customers are asking for new and competitive solutions to drive their own organizations. We need to embrace digital change to remain competitive and relevant.
It's not okay just to be a builder. We need to understand the development aspect in the early stages, the construction, post-construction, and frankly, how the building is being used by its occupants.
4 years ago, we had a 4-pronged digital strategy that involved migrating to cloud compute, business intelligence and analytics, smart integration, and mobility. Microsoft and its Azure technology and platform have been a game changer for us relative to driving that strategy.
The Stantec Tower is an iconic project. It is the largest building outside of Toronto in Canada.
This is a LEED Gold certified building. We've relied on technology to implement our construction planning, from virtual reality, 4D scheduling, and HoloLens technology.
A smart building is a win-win for the owner, the operator, and the tenant. You're putting in the core infrastructure to make it flexible enough in the future. PCL created JobSite Insights, an IoT-based smart construction platform based off of Microsoft Azure, Azure Digital Twin, and Azure Maps technologies. It starts with instrumenting a job site with various IoT sensors, and then streaming that data in real time through the lifetime of the project
The platform actually gives us physical hotspots in the building. They show red areas, which will drive us to go to that area and find out what the problem is. In a building this size, we're relying on our Job Site Insights platform to monitor the temperature, humidity, and pressure in 483 units. That's something that would normally be done by hand.
Our cloud-based information is more readily available. It facilitates collaboration, so we can have all interested parties with the right information at the right time.
By gathering data from sensors instead of people, we can focus those people on more effective and efficient things that drive value back to our owner.
PCL spends $200 to $300 million a year on energy. With Job Site Insights, we anticipate 15 to 20% savings just in fuel and electricity costs.
We have a significant opportunity to change the face of construction through the use of digital technology. Without the cloud, we would not have been able to do the things that we're doing today. As we continue to drive along our digital journey, Microsoft's going to be a critical partner for us in our evolution.
So we're super excited about that. That's where all of our development efforts are focused at the moment, where we're taking IoT on the job site and applying it directly to construction operations. We have a laser focus on field productivity and what my boss calls operational excellence, and this is really helping us. This is a screenshot of the application operating at the Sky Residences. The data is fictitious, we don't never show real data, but what it's really enabled is to monitor the environmental conditions on a job site, which seems trivial. We're starting to progress into the use of that data, combining it, and here's the key, combining it with other data to start making predictions about why is a job site successful? Why is a project successful? Why is a construction project unsafe? What are the correlations? More importantly, what are the causations? And data is the key to that for us. Here's some numbers, startling numbers for us. You heard that we spend up to $300 million a year in energy on job sites. On one particular project, our JSI platform delivered those kind of results. Why? The ability to anticipate heating and energy requirements in response to predicted environmental conditions. A simple task of turning off a heater or a light is significant on a job site. And that's where we're moving toward. I talked earlier about automated decision making. The ability to automate that equipment in response to data and machine learning algorithms that are saying your heater should be turned off or it should be on. Not just simply turn it off because it's hot, turn it off because it's going to get hot and anticipate that. So the use of weather data figures into our platform. Phenomenal savings on a construction project. These numbers are remarkable and contribute to our margins significantly. There we've incorporated into Power BI the telemetry for descriptive analytics. Guys can carry an iPad around a job site and immediately see environmental factors. So it's early days for us on IoT, admittedly, but we're making the big investments in this space. That's our IoT story in a minute or less. I want to talk about two final things. Our machine learning journey, data scientists do not grow on trees. They are a rare breed. They're also sometimes hard to hire. Oh, sorry, pity the data scientists in the room. We've announced a partnership with AltaML to provide that brain power, that intellectual capacity that allows us to build these models. We announced that partnership in March, and now we're starting to execute statements of work on some unique projects beyond JSI into other things such as productivity measurement, safety measurement, and safety optimization. So we're really looking forward to working with Corey and his team in this space, and they've been phenomenal partners. Last thing I'm going to talk about. IoT devices is a low margin business. The vendors do not make a lot of money on this. One of the biggest problems we've encountered is that they're smart. They realize that data is the value, and they charge a lot of money, not for the devices, but you want to get to their cloud and get that data. We didn't want to play that game. We're not going to play that game. We want devices communicating with our cloud, Microsoft Azure, and we launched a challenge through Alberta Innovates under the premise of energy reduction to invite Alberta startups to build us IoT devices. So just yesterday, Alberta Innovates met with their selection committee. Actually, it was deferred to today. I don't think the election had anything to do with that. And we've shortlisted 4 vendors. This is in the public domain. It's MC Things out of Calgary, an IoT vendor. Latium out of Leduc that makes transportation, logistical software and devices, and Campbell Scientific here in Edmonton, in Northwest Edmonton. Our objective here is to have them be funded by Alberta Innovates to produce for PCL a low-cost, construction rugged, communications-capable IoT device. It's really hard to get comms on a job site. It's not like here where we've got high-speed internet, right? That's a huge challenge. LTE-M is the way to go for us. It's the way the industry is going in Europe. Conversations with the industry have indicated this is the way to go. So again, our focus is on environmental stewardship is here. You've seen the energy savings that we realized by actually paying attention to how much energy we consume. That's all I got, folks, and I hope I've respected the time budget. Any questions?
5 minutes for questions. Okay. The number one feedback is people can't hear us.
The sensors that you have on site, they affect the heaters automatically at the moment, or is that the next stage?
So that's what we're striving for, the command and control, if you will. A couple of challenges around that. We rent a lot of equipment, so United Rentals may not necessarily allow us to go slap a device on a heating instrument without some discussion that we're willing to participate. So right now, that saving energy, superintendent gets a notification, or a job site person gets a notification about the environmental condition and managing rocks over there. The nirvana, the holy grail for us is automation on that process.
Okay.
That's challenging as well, right, because there's safety concerns. You can't just automatically switch on a heating device, for example, what somebody's in proximity to it, or there's a piece of equipment or material that is a source of fire or ignition. So there's a lot of technical challenges. Job sites are very sporadic, very chaotic. It's not a manufacturing process. You have strict control over your environment. So construction introduces a lot of challenges for automation. And unlike a factory where you have that luxury of control, that doesn't exist on a job site. And if you've ever attended them, they are quite chaotic. Although organized, but they are chaotic. Where you at? I'll let the next speaker because I'm sure on your time.
All right. Thank you. All right, so I'll introduce our next speaker, which is Brian Matichuk of HealthGauge, plus another startup that he's going to tell you about, which is really interesting for us. But before he starts, just two things. For the first time, maybe ever in the history of Lunchalytics, we're actually going to send out a survey, partly just so we can improve these events for you. We've been doing it for a long time, and partly for us to really understand who our audience is. Like, how many of you are data practitioners? How many of you are data, like, are you practitioners of data science? Yeah. And how many of you are managers? Okay, and then the rest of you? So yeah, this is why we're going to send out a survey. I think it just helps us to understand. And the other thing too, I'm really going to request in there is if you have any feedback on topics you want us to cover, or even companies that you want us to highlight. I went to a different meetup last week, and I have to tell you, this woman commented that we lose a lot of talent in Edmonton because people don't know what cool things are happening here. And I think Lunchalytics really is the opportunity to highlight some of the cool companies and startups that are happening here. I think, the feedback after having Meadow AI earlier this year was really fantastic. And I think HealthGauge will probably be similar as well. So any kind of feedback you guys have or any suggestions for topics or speakers would be really, really appreciated, because it's been 4 years. And so it's hard for us to find something new every month. So yeah, any help would be great. Okay, so I will pass it on to you, Bruce.
Okay, thank you. Bruce, not Brian.
Oh, sorry.
But that's okay.
More Brian.
Brian, I'll answer anyways. Okay, so I'm going to go over these things. So I'll talk a little bit about AI, talk a little bit about history, examples, and then conclude with some AI and IoT. So most of this is actually from a talk that I give that's a couple of hours long. So I've compressed it down to 15 minutes. So if it goes really, really fast, it'll be like, ooh, okay. So, but there's lots of pictures, so hopefully it'll be entertaining for you. A bit about my background. I have a master's and work on PhD in AI, basically, but most of my career has been actually spent trying to get AI into startups, like actually build startups. And so we have kind of an IoT. So this is HealthGauge is an IoT company, because really what we're doing is we're treating the body as a source of data, and we're building sensors that can actually help you with your health. At Aiden Intelligent Technology, which is another company that I'm working with right now, we're building intelligent video systems. So we can talk a little bit about that. And if you have some questions, love to come talk to me afterwards about that. So a lot of people don't realize that U of A is one of the top AI institutes in the world. Actually, in this particular graph, we come up as number 3 actually in the world, ahead of MIT. So that's really an interesting stat. A lot of people don't realize. So what is AI? AI is the whole study of how do we make things smart like people. That's basically the idea. And I think this is probably one of the most important topics of the age for a few reasons. One, of course, AI has the ability to change everything. Imagine if we can make systems that can think and act and do things that people do. This is where we're heading. And so, but it also has some pretty negative impacts too, I think, in the world. And I think it's important that we don't lose sight of that. But it's also a mirror into ourselves, and one of the reasons why I love to study AI. So just a few common topics, introductory topics that I always talk about right at the start of these AI talks. Turing test. Anybody hear of the Turing test? Right, so a few of you. So the idea, Alan Turing, who was the subject of the imitation game, he built this device, this computing device that was actually a mechanical computer, but he automated thinking, and he realized that if computers could ultimately think with infinite capabilities, they'd be like people. And so this idea, if they were thinking like people, then you'd probably have to say they were intelligent and thinking like people. So strong AI is this idea that AI systems can think and have a mind. Weak AI is this idea that, well, do we really care if they have a mind? If they can think like people and do the things that people do, then that's really what's important. There's also this idea behind general AI versus narrow AI. So narrow AI, an example of that is like a Go player or a chess player. This is very narrow, but what we're now building in the AI world is systems that are much more general in their capability, and that is the ability to actually have a conversation. So a chess player, for instance, you couldn't actually tell it to go and take out the trash, but maybe someday you will. That'll be a general AI idea. And that also leads us to this idea of the AI singularity. What happens when AI is so smart that it can actually build itself? Well, the point after that is really inconceivable in terms of how society will change and evolve once AI is actually building AI. And we're actually at this point now where we are building AI systems that build AI. So this is how much progress have we made? This is a computer from the late 80s, 1.9 gigaflops. It's hundreds of millions of dollars, helium cooled, 1.9 gigaflops. So this is an iPhone. This is 600 gigaflops. So an iPhone is 300 times faster than a Cray computer. And so what can you do with that kind of computing power? You can make some pretty smart things. So this is the IBM Summit. This is 200 million gigaflops, right? And they've just announced the Frontier coming out very soon, which is 1 billion gigaflops. So the computing power is really there to do some pretty amazing things that seem, seem human-like. So here's computer performance, human performance. We're really there. So a little bit about the history of AI. I'm going to go through these really fast, but there's pictures. So, started with clocks. This is the bomb. This is Alan Turing's mechanical machine. And ultimately, we had vacuum tubes, right? And that ultimately led to transistors. And of course, this drove the idea of thinking machines quite a bit as we made these machines smarter. Initially, we couldn't really make them smart enough to do anything useful, but we figured out that we could make robots to do human labor. And of course, that was really the introduction of the most recent industrial revolution, which is the robotic industrial revolution, which started around the 70s. We started to build these neural nets. So these things are mathematical entities that function like in a similar way to the way that the brain functions. And we figured out how to actually tune all of these billions of weights. And that was a major discovery in the area of AI. You can kind of see how we got towards the end of that to the 90s. So 90s, some things start really happening. We start building, self-driving cars, 94. Deep Blue beats the world chess champion. Many people thought this would never happen. And yet, here we are in 97, it's happening. So RoboCup, this is robots playing themselves in soccer, which is kind of cool. All right, so now self-driving cars that really work. Siri, right? Can actually talk to it and it can do your stuff for you. Here's major innovations in the last decade. Watson, Google, DeepMind feeds Go, DeepStack. It's actually play, again, out of the U of A. A lot of this stuff comes out of the U of A. I like to point that out. People don't realize that. AlphaGo Zero defeats, this is a Go player, right? What we've seen now in the last year is hyper-realistic AI, where we can generate images that look like people. We can generate natural language that it looks like somebody wrote it, like it looks like a person wrote it. Sound creation, music, we can actually generate long pieces of music and you can't tell that it was actually generated by a computer. Deep fake, maybe some of you have seen this stuff, it's pretty scary. Now we're starting to get into AI-assisted hyperparameter tuning, where the models of the AI are actually being created by AI. And this is now happening, and a lot of the innovations you see coming out right now are based on these ideas. There's a huge education explosion. So all of the major educational companies are now putting all of their courses online, and you can learn all about this stuff. And in a lot of cases, like EDX, for example, go look up EDX. It's all free. Like you can get an entire university course in AI for free. And of course, there's the tools explosion. So Microsoft, Google, IBM, every one of these companies have toolkits now where you really don't have to know a whole lot. You get on there and you can create incredible AI systems. And then embedded AI. So I'm going to just, okay, where is that? Is that not happening? Oh, it's probably, okay. Okay, so AlphaGo, you all saw AlphaGo. So DeepMind, a team actually located now here at the U of A, they figured out Go. So Go is an interesting game because it's really hard. The number of states of a Go game exceeds the number of molecules of the universe, right? So, yeah, just keep going. Okay. So what's interesting about AlphaGo Zero is that this is done using self-play. That's why it's called Zero. So where did all the data come from? It generated its own data in order to become intelligent. And within a few hours, it's able to replicate all of the knowledge of mankind of 3,000 years of play in a few hours just through self-play. Okay, let's keep going. AlphaGo Zero. Let's go, so based on AutoML. So duplex, if you ever go, so yeah, go back to the next slide. If you go online and look at the duplex example from Google, it's so interesting because it actually has a conversation with people and you can't tell that it's actually a machine that's actually having this conversation. Okay, so let's keep going. So that's duplex. So now we get into creative computing where these machines are actually generating things that you can't tell. LSTM, this is a major innovation in the AI community where we're actually able to remember long chains of reasoning in our machine learning models, hundreds of sequences long. Again, this is a new technique called generative adversarial networks where two neural nets compete with each other. And by competing with each other, they're actually to make each other smarter. And so go ahead to the next slide, some examples. So what do you guys think about these faces? Has anybody seen this GAN example before? A couple of you? So none of these faces are real. These are all generated by a machine. And it's, my wife said, it's scary because it looks like they have a soul, Like this is, like really, you can't tell. Like right down to the little, zits or whatever, and the spaces aren't symmetric. These are realistic. And see, these are generated by intelligent systems. So next. So here's some text. It kind of looks not too bad. So this is generated by a machine. Another example, go ahead next. So this one's actually starting to get really good. So you give it this sentence as input, and it automatically generates this entire phrase. And in fact, this technology now is used in the news industry today, where a very small amount of key words can generate an entire news article in specific areas like weather and in sports. And it looks like it's done by a person. Okay, next slide. So look at that handwriting. You give it some example. These things look real. These are done by machines, not done by people. Okay, so next. So Steve Buscemi. So you can go online and find this. It's hilarious. This thing, it is him talking, and Jennifer Lawrence. But it's basically it's using all of these other technologies that I was telling you about, and it's really hard to tell that it's actually fake. And these are getting better and better. And probably in a year's time, you will look at that and you will not be able to tell that it's completely fake. Okay, next slide, deep style. So this is really interesting. So Van Gogh painting, okay, the AI analyzes the painting. It then takes a picture, that you took, and it again can actually generate a painting that was done in this style. Has anybody seen deep style before? Some of you. You can actually go and download deep style, get it on your PC, give it one of your pictures, and you can actually generate a Van Gogh for yourself. That'd be fun. I tried it. It's really fun. Okay, next slide. You can then combine multiple styles and create artistic works completely automatically that really are really interesting if you're into that sort of thing. Actually, I like that one. Let's look at that one in the bathroom, maybe. I don't know. Okay, so next. Real-time strategy. Can AI? So these games have like 5 people interacting together with complex strategy. And OpenAI, which is an AI company that generates AI, they came up with this and they made this all public. So you can create, implement that and beat all your friends. Okay, so next. Human dexterity. This thing, like if you watch this video, it looks like a person doing stuff. He's trying to manipulate these and he's got this goal here that he's trying to get to. And it's very good. Okay, so next. Has anybody seen Boston Dynamics? These are hilarious or scary. So this thing is actually doing a backflip, right? And if you go up to Boston Dynamics site, you can see videos of robots that are running, leaping, dancing. No, I don't think there's any dancing ones yet, but that'll be next, right? They'll be, dancing. But they do have one where it, moves a bunch of boxes onto a platform. It's like, what do you need people for? That's really interesting. Okay, keep going. So AIT. So the Internet of Things, it's getting smaller, it's getting faster, it's getting smarter. Let's go next slide. So sensor costs are significantly declining. Like these things are getting tiny, and the processing is getting tiny, and the memory is improving. Like, so yeah, so look at this. This is a full computer with communications capability. It's 1 millimeter by 4 millimeters, so that's pretty small, right? And it's a full computer with sensors, actually, as well. This is IBM's response. This is a full computer. It's 1 millimeter by 1 millimeter. And it's a full computer. It has optical transmission. You can interact with it. You can run software on it. Oh, check out this one. That's a grain of rice. This is a full computer. It's 0.3 millimeters aside, right? So think about the IoT industry. You could put that in your body. You could put that in a person's brain. You could put that in all kinds of places that you don't want to talk about. And that would be, you know, that's IoT, right? These are sensors. So this is a CO2 sensor. This is a pressure sensor. Think about how big these things used to be, you know? And now look how small that thing is. Isn't that amazing? So the sensors are shrinking. Memory, okay, 250 gigabytes. Actually, I just saw another one. It was a terabyte, and it's my fingernail size. This is a 1 terabyte memory stick. 1 terabyte memory stick. And you know how much this is? You can get this for under $100. A terabyte. This is 100 terabyte drive. And it's an SSD drive. It means pure memory. 100 terabytes. And it's not that expensive. And they're getting cheaper. So these kinds of things are driving the IoT industry. What's also driving the industry is all of the hardware that the companies are making to make that processing small and generally available. So we've got the Google TPU, Intel has got their chips, they're doing neuromorphic computing. This is something called the Edge TPU. So look how small that thing is. That has as much processing capability as as a few years ago, which would have been a computer, that size. And it's about that big now. So this is out now, and in fact, we also have these things called micro modems. These things are so tiny. It's a full cellular modem with GPS capability. You can embed this in stuff and have it everywhere. What's also happening is the maker community is evolving. So this is a really interesting innovation. Arduino, Raspberry Pi, and even I call it micro Unix, because full Unix kernel, you can run it. So this is a device that's just come out. It's called the Jetson. This is actually the Jetson Nano, and it'll run Ubuntu. And it has full capability to do all of your IoT, and it's this big. This is a Raspberry Pi. This is the Arduino, really tiny. And the cool thing about these things, you don't have to know very much about electronics and firmware, right? So in our company at HealthGauge, we actually built the whole firmware stack using, a Nordic CPU. And holy mackerel, what a lot of coding to get that firmware up and running. This thing you can have up and running in an afternoon and do IoT with it in an afternoon. And in fact, there's a chip that Google's just come out with, the Edge TPU, where you can attach this to a neural net, Edge TPU, and you can take TensorFlow models off of the neural net and run it. All right, so I think I'm just about done, right? All right, so why don't we just end it there? So IoT is amazing. These are all the things that are happening in IoT. All right, thank you. Any questions? Questions, come on, questions. Okay, first one that's a question gets a hallway. You guys know what the hallway is? Have you ever eaten? Oh, the burgers are to die for at the hallway. Okay, you go.
Have you working? Yeah. Okay. Have you put any thought into kind of the ownership of AI? Because if something is truly autonomous, like who owns it after that point then, if it can think for itself?
I own it because I made the AI.
Yeah, but then it can make decisions on its own, right?
Well, yeah, but but I made it, so I want to own it and make lots of money from it. So that's a really interesting question. I mean, this is and often debated, right? Because as these things become much more autonomous, really the intelligence of AI comes from the data. It comes from the algorithms, but it also comes from the data, right? So you throw different problems at it, and now you get it can do things that I didn't make it do it. It did it. It figured it out. It actually invented it, right? Like these artworks, right? I mean, just took a bunch of data and made some new art, but it's still not general. So I'm just taking away its property rights and reselling them. So
When they can make that decision for itself.
when they make it for themselves, look out, because they'll be reaching into your pocketbook for sure. So. So that's a good question. Another one. Who else got a question? All right. Going once, going twice. Another hallway pass. All right. There you go. All right. There you go. Woo.
So should we be excited or terrified? Like how far away are we from Skynet?
Both. I'm terrified. I've been doing this for 30 years. Originally graduated '86, and of course, I've been doing this in businesses ever since. And I'm so excited because in the last couple of years, we've seen AI, like things that we struggled to do. Really interesting. So I worked on deep learning neural nets back in '86. People talk about Hinton. He's just got this Turing Award in computing for deep learning, right? Well, I worked on those models back in '86, and we had, digital handwriting recognition. And so then I'd put this thing into into our VAX computer at the time, and it would run all day long, And at the end of the day, 1. Yes, it's a 1. I don't want, So, and now these things are blistering fast. They can recognize the face. They can recognize 10 faces 30 times a second inside of a video stream. Wow, the capability of AI has gone from we can't do anything to it's everywhere and it can do crazy stuff. I believe that within the next decade, we will see systems that you can interact with it, that you can't tell that you're having a conversation with some AI system. And so I'm terrified. I'm terrified for a couple of reasons. One, of course, is that it's going to have a huge impact on the job market. And how does that change side? We're already having a problem where, you look at GPU. GPU has gone up consistently over the last several decades, since the 70s, but yet the wages of average workers have actually remained flat, and in fact declined for people that aren't, super rich already, right? And the reason is it's intelligence, it's automation that's doing it. So we have to now, today, recognize this is coming and take steps to make changes, because it's just going to steamroll right over us as a society. I'm terrified, but I'm also really excited because I think of all the cool, amazing things that AI can do. So in Health Gauge, we're using AI to actually do predictions about your health. And it's fantastic. I mean, I've wanted to do this my whole life. I'm doing it now because the technology exists. Put sensors on your wrist, and I can do crazy diagnosis about your health and think about all the applications. We're doing a project with Bill and Melinda Gates Foundation in Bangladesh to help women with eclampsia. And the reason that this is possible is because they can strap on this device onto their wrist and it can monitor them. And that would not have been possible at any other age or any other time. So I love it, but we have to think about those issues. But thanks for asking that question. I ran out of hallway cards. Did you have another question?
I did, but you started answering it.
Okay.
So, I don't think this is on. It is? Okay. So how do we, as good data practitioners, because you hinted at it already, that the benefits of AI and technology don't necessarily go to the people who benefit from it the most, right?
Yeah.
And so what are steps that we can take that you think that we could do to help make sure that they do receive those benefits outside of one-off projects, like in the long term? How do we enshrine it into policy, into our management, into our industry?
Well, I think those are exactly the questions that we should be asking ourselves with politicians, with industry leaders, with business leaders. Do we make technology freely available? So maybe we charge some people who can pay, but those who can't, you get to use it. Because honestly, we're reaching this position of infinite wealth. AI and machines can generate can reach all of our needs, way more than we can even consume what can be generated. So should we still be charging people enormous amounts of money for all of these things? You have to charge something, but how do you distribute wealth? Maybe we need universal basic income. Maybe that's a good idea. I don't know. But I think these are the questions of the age, and we have to start trying to answer them. Good questions.
Last question, sorry.
Last question, right there.
Sorry, I'll take the mic.
I really find all of this innovation in analytics and data science fascinating. But as I dig in, I actually realized that most of the techniques and algorithms that we're applying right now are things that were developed at least a decade ago, even going further. So my question is, do you think there's still room for innovation in primary research, or do you think that all of the value going forward would be from applying data to all of those algorithms? Do you think there's anything new to be discovered? Are we just going to throw more data at the same old algorithms and discover new insights?
Oh, there's always more to discover at a fundamental level, right? I mean, physicists keep asking this question about, physics. Every area of science, you kind of reach this plateau. But I think exactly what opposite is happening right now in AI. I think we're reaching a place where now we have these amazingly powerful tools that can actually help us to analyze the systems that we're building. We can build systems with billions of variables that do super intelligent things. Well, now what we can do is actually use those tools to help us analyze the very AI that we're trying to build. And I think that in the next decade, there'll be an explosion of discoveries that are fundamental discoveries about thinking and intelligence and how to make machines super intelligent. But thank you for the question.
And with that, thank you very much to Bruce for speaking today. Sorry. All right, so thank you once again for attending our April Lunchalytics session. We'll see you, the next one will be May 15th. And then we're just asking if you could take the chairs that are not behind the tables, the ones without the arms, if you could put them away on the sides before you go, that would be fantastic. And the speakers will be here if you have any other questions. Thank you.
Yeah. Well, that's fun.